Okay, so we're now in a new module, one of my absolute favorites, numerical differentiation integration. And as you know, most all good things in calculus and other areas come from the Taylor series. I don't know what that man did, but the Taylor series is something that is absolutely amazing. Okay, so let's think about how we learned differentiation when we learned calculus. Okay, so in the beginning, when we first learned calculus, we were given a curve. And so when you're given this curve, you are given some point xi. And then you are given a point xi plus h. Okay, so here is xi plus h. And then somebody draws the secant line between the 2 points. And they tell you the slope of the secant line. All right, so they say first, the slope of the secant line let me just say this distance is h. So the slope of the secant line is f, we'll call it m. It is, let's not call it m, let's just call it the slope of the, yeah, we can call it the slope of the secant line for now, it's called m. It is f of xi plus h minus f of xi divided by xi plus h minus xi. Okay, so that's the motivation of this. And then, so that just comes out to be f of xi plus h minus f of xi all over h. And they tell you that is the slope of the secant line. And then we go into what really calculus is about, and that is the derivative f prime of xi is actually the limit. So this is the slope of the tangent line. At xi. And they say in order to get the slope of the tangent line, at xi, you have to take the limit as h approaches 0 of the slope of the secant line. And so we get that f prime of x is equal to the limit as h approaches 0 of f of xi plus h minus f, and this is the f prime at xi, all over h. So we go through all of that in order to get the derivative. But we say for really, 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 really small h's, so for h, really, really small, then the derivative f prime at any x is just really approximately the slope of the secant line. So f of x plus h minus f of x all over h. And so we use this to approximate our derivative. So that's our first approximation ever that we've ever seen or we ever use of the derivative. okay? And so basically we have what we're going to call the first order forward difference derivative. So the first order forward difference formula, and this is for f prime of x. All right, so the reason why it is the first order forward difference is because given a set of points, so given a set of points, here's a point, here's a point, here's a point, and here's a point. If I want the derivative at this x right here, I'm only going to use the one in front of it, which is x plus h. So I'm only going to use those 2 points in order to find the derivative. Okay. So given some function f of x, I want to find an approximation for f of x. So I can only use those 2 things. And so this term, this x plus h, I am going to develop a Taylor series approximation about that point. So I get f of x plus h is equal to f of x plus f prime of x times h plus f double prime of x times h squared over 2 factorial. And then I get plus f triple prime of x times h cubed over 3 factorial. And this thing continues on and on and on. So I want to now solve for f prime of x. So here is my f prime of x, and this is what I need to solve for. So I'm going to move it to the other side, everything to the other side. So I get f prime of x times h, turns out to be f at x plus h minus f of x minus f double prime at x h squared over 2 factorial minus f triple prime at x h cubed over 3 factorial plus or minus dot, dot, dot. Okay. So now when I solve for f prime of x, I get f prime of x is equal to, I'm going to take this f of x plus h and this minus f of x and divide that by h. Then I'm going to take the next term and divide it by h. So I get f double prime at x times h over 2 factorial. And then I get minus f triple prime at x times h squared over 3 factorial. And that continues whatever it's doing. And so now let's just chop it off. So we are going to chop it off right here. All right, so when I do that, I now get that f prime of x is approximately f at x plus h minus f at x all over h, because I'm assuming what's left is really small, and this is something of order h, okay? Because here is my order h, something of order h, that's the highest power. So this becomes the forward difference formula. And that's what we can use in our code to approximate the first derivative. Okay. So say we have, here's an example. I have my function f of x is equal to the log of x. And my x naught that I'm concerned about is 1.8. So f prime of 1.8. Well, the derivative is just 1 over x. So this is 1 over 1.8. And this comes out to be 0.55556. Obviously, it keeps going. Okay. So now we're going to try to figure out what this derivative is at f prime at a, at f prime at 1.8. All right, so say we let at h be 0.1. So now we have f prime of 1.8 is going to equal f of 1.8 plus h minus f of 1.8, and we are going to divide by h. All right. When we do that, the number we get is 0.54067. Not too bad of approximation. It's got some error. We can figure out the error, but it's really, that's what it is. Okay, so now what we want to do is cut h by a factor of 10. Okay, and then what we see is the error decreases by a factor of 10. Okay, so here I need to draw a table. So this is going to be h, and h gets to be 0.1, 0.01, 0.001, and 0.0001. This, using the formula, turns out to be f prime at 1.8, and this is our approximation. So we get 0.54067. Okay, then if we decrease this by 10, we get 0.55402. So now I want to draw another column. that I am going to call error. And this error is 0.01335. Where's my calculator? So I have clear 0.5556 minus 0.54. Okay. If I here, I get 0.55540, and this error is 0.00138. And then here I get 0.55554, and this becomes 0.00014. Okay, so you can see that the error decreases by 10. Okay. All right.
Excuse me, ma.
Yes.
How did you go about that? I really don't.
Okay, so let me see here. Let me check here. Checking my numbers. So 0.55. Ooh, we'll go back. Okay, so this is the first iterate. If you look at the difference between, if you take 55402 and you subtract 54067,
Okay.
you get
Oh.
0.1335.
Okay.
And then if you take 55540 and subtract 55402, you get 0.00138. Okay. All right. So I'm trying to think about how I go from one. I have one. Oh, that was A. Okay. I can do the same thing. Same points. So let's go up here and I'm going to grab these same points. Okay. We can also talk about the first order. backwards difference formula. Okay, so this time we're going to have a point X, and the point behind it is X minus H. So now we are going to do a Taylor series about that. All right, so again, given f of X, we want to find f prime. Okay, so now the Taylor series f of X minus H is f at X minus f prime at X times H plus f double prime at X times H squared over 2 factorial minus f triple prime at X H cubed over 3 factorial plus or minus dot, dot, dot. So now again, I'm solving for f prime. So now I get f prime at X times H is equal to f at X minus f at X minus H. Then I'm going to get minus, I get plus f double prime at X times H squared over 2 factorial. And then I get minus f triple prime at X H cubed over 3 factorial plus dot, dot, dot. Okay, so now when you divide by H, you get f prime of X gives you f at X minus f at X minus H divided by H. And then I'm going to get plus f double prime at X times H over 2 factorial minus f triple prime at X times H squared over 3 factorial plus dot, dot, dot. And we're going to do the same thing. We're going to chop it off. So when we do that, we get f prime of X becomes approximately f of X minus f of X minus H divided by H plus order H. So this is now a first order backwards difference formula. Okay, so we've done a backwards difference formula, forward difference formula, and a backward difference formula. Okay. So that is, so as you can see, so whatever H you pick, so say I pick H equal to so let's say whatever H I have, I then reduce H by 2. Then I'm going to reduce the error by 2. Because it is a first order approximation. Okay. I now want to derive the second order forward difference formula. So this one, the error is going to go down by h squared. All right, so I'm going to draw my picture again. Okay, so this time, I still want to derive the derivative at x, but I'm going to use x plus h, and I'm also going to use x plus 2h. So I'm still trying to get the first derivative, still trying to find a difference formula for f prime. I haven't tried to do anything yet different. I'm only deriving a difference formula for f prime at x, not anywhere else. So this time I'm going to need a Taylor series, f at x plus h is f at x plus f prime of x times h plus f double prime at x times h squared over 2 factorial plus f triple prime at x times h cubed over 3 factorial, and I'm going to go out one more, plus the fourth derivative at x times h to the fourth over 4 factorial, and plus dot, dot, dot. Okay. So now I need f at x plus 2h. So this is f at x plus f prime at x times 2h plus f double prime at x times 2h squared over 2 factorial plus f triple prime at x times 2h cubed over 3 factorial plus the fourth derivative at x times 2h to the fourth over 4 factorial plus dot, dot, dot. Okay, so now here is where life gets fun. I am trying to solve for f prime of x. And in order to do so, I'm going to create a linear combination of these two things that will help me get there. So I'm going to multiply the first equation. Let's see. I think so. So when I do this, I know that I want to be able to solve for f prime. And I don't care if I have f prime, and these things in my equation. So what I'm going to do, I'm going to multiply the first equation by 4. And I'm going to leave the first equation as it is. So now I am going to take 4 times this is the first equation. Let me call it, I should have given them names first. This is equation 1. This is equation 1. And this is equation 2. Okay, so now I'm going to take 4 times the first equation. So 4 times the first equation minus the second equation. And let's see what I get. So on the left-hand side, I'm going to get 4 f at x plus h minus f at x plus 2h. So that's what I get on the first side. On the right side, I have 4 f at x minus f at x, so I get 3 f at x. Now I'm going to get 4 f prime at x times h minus f prime at x times 2h. So that's going to leave me 2 of them. Okay. Then the next thing, I'm going to have 4. Oh, wait a minute. That's over 2 factorial. No, it is not. Okay, that's right. The next term drops out. These 2 terms, 4 times that minus that, these 2 terms actually drop out. That's why I was confused. Now the next one, I get 4 over 3 factorial minus 1 over 3 factorial times 2 cubed, which is 8 over 3 factorial, times f double prime, sorry, triple prime at x times h cubed. Plus more stuff. Hi, Danye, you're early. Okay. All righty. So now I'm still trying to solve for f prime. So now I get f prime of x times 2h is equal to 4, well, is equal to minus f at x plus 2h plus 4 f at x plus h minus 3 f at x. And then I'm going to get 1/3 f triple prime at x times h cubed. And I am feeling like that should be positive. Plus stuff. Okay, so now I get f prime of x times, oh, get rid of the 2h. So now I get minus f at x plus 2h plus 4 f at x plus h minus 3 f at x. I'm going to divide that whole thing by 2h, and then I'm going to get plus 1/3 f triple prime at x times h squared. And that should actually be 1/6 because I divided by 2h. Plus stuff. So I'm going to chop it off. And now I get f prime of x is approximately minus f at x plus 2h plus 4 times f at x plus h minus 3 times f at x. All of that is divided by 2h plus something of order h squared. So this is why this is the second order forward difference formula. Notice it is second. So the error in the approximation is going to go down by h squared. Okay. We save the best for last. The central difference formula. Okay, so this is the central difference I need a better sound. I don't like that sound. Okay, so now I'm going to take my same picture. Here we go. Okay, so this time I am going to center, still trying to find a derivative at x, but this time I'm going to use x minus h and x plus h. So it's called center difference because the derivative is at x, and the points that I'm using around it, all right, make x centrally located. Okay. So we're going to do the same thing again. I sure want to snatch them formulas and not rewrite them, but I'll rewrite them because y'all got to rewrite them. So we get f at x plus h is f at x plus f prime at x times h plus f double prime at x times h squared over 2 factorial plus the triple derivative of x at h cubed over 3 factorial plus dot, dot, dot. And f at x minus h is f at x minus f prime of x times h plus f double prime at x times h squared over 2 factorial plus, nope, that one's a minus, minus f triple prime at x times h cubed over 3 factorial. And that continues on forever. Okay, so this is now equation 3, and this is now equation 4. And what I need to do is take equation 3 minus equation 4. And when I do that, I get f at x plus h minus f at x minus h. And I don't think I went out far enough. Yes, I did. Yeah, but. Okay, so when I subtract, this goes away. And when I subtract, this goes away. So I get on here 2 times f prime of x times h. And I'm going to get 2 times f triple prime at x times h cubed, and it's still over 3 factorial, which I can simply write as 6 because that's a nice, easy one. That is not matching my notes. Yes, it is. Yes, it is. Okay, so now we're solving for f prime. So I get 2. Can I just go for the jugular? Y'all are big people. Y'all grown up. I'm going for the jugular. F prime at x. I'm going to divide everything by 2h. So I get f at x minus 8 plus h minus f at x minus h divided by 2h. Plus, when I divide this by 2h, I get f double prime, triple prime at x times h squared over 6. Plus, don't forget my higher order terms. So now I'm going to chop this off. And I get f prime of x is equal to f at x plus h minus f at x minus h all over. Uh-oh, that is not equals, that is approximate. This is over 2h plus O of h squared. So that is also second order, just like we did the second order for difference. Okay, so I think I might have time to do this example. I have 4 minutes. I'm going to get it in there. Okay, so let's go back to f of x equal log of x again. And so now we're still trying to find f prime of 1.8. And it is 0.5555. I'm going to go out further only because I need you to see the error. So again, f prime of 1.8 is now going to be approximately f of 1.8 plus h minus f of 1.8 minus h. So I'm using the point in front and in back. And that's going to be divided by 2h. So here's my table. This is h. This is 0.1, 0.01, and 0.001. And so f prime of 1.8, we get 0.55613. And so now I let it decrease by 10. So now I get 0.55556. And this is 0.00057. And then this one is 0.5555. Trying to see how many fives I got. 556. And this is 0.0000044. Okay. All right. I have another example. And then we're going to do another, oh, we have several fun things to do. We have second derivatives that we have to do. So, and I'm going to show you how to do the fourth order centered difference, the second derivative. Then we're going to do a Richardson extrapolation, and then we will go on to integrals. Okay. This is good stuff, guys. Good stuff.